Math 8, Unit 6, Lesson 3, Decimal Expansions of Rational Numbers. First, let's talk about the limits of decimal notation. This is kind of talking about how calculators report things. There's three ways you can report decimals. You can use rounding, where you pick a decimal place and then round it, and then cut it off at that point. An ellipsis at the end, which shows continuation. And you can also use an overbar. For example, the fraction 16/33 is 0.48484848. It repeats forever. If I represent it with rounding, I could either record the answer as 0.5, rounding it to one decimal place, 0.48, 0.485, 0.4848, etc. If I use an ellipsis at the end, it indicates that the pattern repeats the 4/8. It's just says the pattern that you perceive there is going to continue. Probably the best way on a repeating decimal is to use the overbar notation, where we put a bar over top of the digits that repeat. Okay, another thing, let's take a look at pi. Now, pi can be represented with the rounding. This is how we tend to usually do it. Example like 3, 3.1, 3.14, 3.142, 3.1416, etc. And the other ways of trying to represent pi, you can use an ellipsis at the end, just indicates continuation. There's no pattern to it there. Now, for the overbar, we can't represent pi with an overbar notation because it doesn't contain a repeating block of digits. The main point in this lesson is going to be about converting decimals into fractions. We're going to do it with solving equations. The first step is to let x equal your decimal. And you're going to multiply both sides by 10 enough times so that you no longer have a decimal. And in this case, we end up multiplying by 100 on both sides. And after we multiply by 100, I'm going to go ahead and reset that. After I multiply by 100 on both sides, we have 124. And then we can divide both sides by 100. And the way this is going to work to transfer it into a fraction form is that we are solving, but we're going to solve using fractions instead of using decimals. So we do get the answer of 124 hundredths, which we would reduce as much as we can. And we do get 31 25ths, which, if you're interested in the mixed number, that's 1 6 25ths. Okay, negative 0.555. Same process. We're going to start by making it equal to x. Then we multiply both sides by a big enough power of 10 to make it so there's no decimal places. And in this case, since there's 3 decimal places, we will multiply both sides by 1,000. So 1,000x is negative 555. And then divide by 1,000. So we multiply by 1,000 and then divide by 1,000. And then we reduce. Top and bottom here can be divided by 5. And I get negative 111 over 200. Okay. Next, we're going to try to do the same thing with a repeating decimal, but we're going to run into a problem here. If I let x equal 0.54, repeating, what do I have to multiply by to get past all of the decimals? Well, there's an infinite number of decimals. If I were to multiply by 100x, I would get the 54 out, but I'm going to have 5 4s going forever. So you can't multiply by a big enough number to make them go away. Here's a first few of these. One thing we can do, though, is we can just use more than one of these. And a nifty little trick, consider 2.48 minus 0.48? Well, that would just be 2.00. That's the trick we're going to use. But if it was repeating the decimal, then these 4/8 would go forever. But each one individually would subtract away to 0, and we would just be left with 2. So if we can find the exact same decimal parts, we can subtract and get rid of them. And that does happen right here. We've got 0.54 repeating on both of those. So let's take 100x, which is 54.54 repeating, and we're going to subtract away from that x, which is 0.54 repeating. And when we do this subtraction, 100x minus x is 99x. 54.54 repeating minus 0.54 repeating is just 54. Then we can finish the solve by dividing both sides by 99. We can reduce the fraction by dividing top and bottom by 9. And we do get 6/11 as our fraction. The nice thing about these problems is you can easily take a calculator, take 6 divide 11, and check your answer. Let me pull up a calculator here real quick. Wrong thing. Calculator. Okay, if I do 6/11, 6 divide 11, I do get 0.5454. I do get the right answer. Okay, let's do 0.7 repeating. We'll start by making x equal to 0.7 repeating. 10x is going to be 7.7 repeating. And actually we've gone far enough. These have the same decimal parts. So let's use 10x, which is 7.7 repeating, and x, which is 0.7 repeating, and subtract them. We get 9x is equal to 7. Divide both sides by 9. 7/9 does not reduce, so the fraction is 7/9. And sure enough, if I divide that, let's take 7, divide 9, it does equal 7 repeating. Remember that 8 right there is just from rounding. Okay, here's the notes that you can pause and write down if you'd like the notes. I'm just going to read through them. I can convert a rational decimal expansion into a fraction. You need to know that a rational number is a ratio of integers, for example, 3/4, -60 61st, 91 hundredths, 2/13, 4. 4 can be written as a fraction, 4/1 or 8/2. Every rational number that can be represented as a decimal that will either terminate, which means it'll end, or repeat the same block of digits. An overbar, and for those of you who like fancy vocabulary words, a vernaculum, is used to denote repetition of a block of digits. Well, here's an example of a terminating decimal, 0.53, and then it stops. An example of a repeating decimal, 3.445. The bar over the 4/5 indicates that the 4/5 repeats, but not the first 4, just the one with the bar on top. If you have a terminating decimal, you start by letting x equal the decimal. You multiply both sides by 10 until no decimal place remains. Then you divide and reduce the fraction. If it's a repeating decimal, you start with letting x equal the decimal. Then you make a list, x, 10x, 100x, etc., until you find two numbers with the same decimal parts. You can subtract the two equations and divide and reduce. Here's a couple of examples. On this one, you're going to convert 0.124 into a fraction. You start by letting x equal the 0.124. I multiply both sides by 1,000. Then I divide by 1,000 on both sides. Reducing, dividing top and bottom here by 4 gives me 31/250, which is the correct answer. 31/250 is 0.124. That is correct. Now for this one, let's change 0.124 0.1072 with the 72 repeating. First, you want to let x equal that number. And here I've written it in ellipsis notation with the dot, dot, dot at the end. You make a list. I've made a list of x, 10x, 100x, 1000x, 10,000x. And I stopped there because at that point I had found 2 with the same decimal parts, specifically 7272. So 72 repeating. The next step is I go ahead and subtract the equations. I'm going to take 10,000x minus 100x, and that gives me 1,072.72 repeating, minus 10.72 repeating, and that gives me 9,900x equals 1062. I go ahead and divide both sides by the 9,900, and I reduce, dividing top and bottom by 18 in this case, and I get 59 over 550. And if I check my answer on that, 59 550ths, let's try that again. 59 divide 550. It checks out to be, that's not the right thing. I must have typed something in incorrectly. Let's clear the memory. 59 over 550 is 0.107272. So that does actually match up with that. Let's go over some examples. So changing 0.4 to a fraction, we start by setting x equal to it. Looks like if we multiply both sides by 10, that'll get rid of all the decimals. Divide by 10, reducing the fraction. 4/10 reduces to 2/5. 0.28, start by making x equal 0.28. Multiply both sides by 100. That'll get rid of all the decimal places. And then we can divide by 100. And x equals, well, divide by 4, top and bottom. Looks like it's 7/25. I guess I don't really need the x inside the box. So let's see, that's 7/25. Okay, negative 0.51. We start by making x equal to that. We multiply both sides by 100 because we need to get rid of 2 decimal places, and that gets everything out of the decimal. Divide both sides by 100, and we actually get the fraction there. It doesn't reduce. Negative 51/100. Okay, 3.125. We're going to start by making x equal to 3.125. We multiply both sides by 1,000 this time because there are 3 decimal places. So 1,000x is 3,125. Go ahead and divide the 1,000 away. And x equals, if I divide top and bottom by 25 here, that will give me 125/40ths. Oh, those are multiples of 5, so I'm going to divide by 5. And I get 25/8, which won't reduce any further. As a mixed number, that of course is 3 and an 1/8. Now let's look at some repeating ones. First, you need to consider a list of x, 10x, 100x. It looks like x and 10x both have the same decimal parts. So let's do 10x, which is 2.2 repeating, and x, which is 0.2 repeating. And we're going to subtract those 2 equations. 10x minus x is 9x. 2.2 repeating minus 0.2 repeating is 2. Divide both sides by 9. 2/9 does not reduce. The answer is 2/9. Let's look at 0.8 repeating. First, we need to consider our list. We look for a place where they both have, we got 2 of them with the exact same decimal parts, which happens right away. 10x is 8.8 repeating, and x is 0.8 repeating. If we go ahead and subtract those, we will get 9x equals 8. Dividing both sides by 9, we get 8/9 as our fraction, because it doesn't reduce. Number 7. The first thing we need to do here is consider the x, 10x, 100x, and look for 2 of them that have the same. same parts, and that does happen with x and 100x. So I'm going to take 100x, which is 14.14 repeating, and x, which is 0.14 repeating, and subtract them. That gives me 99x equals 14. I can divide both sides by 99. And 14, let's check to see if this reduces. 14 is made out of 2 and 7. So 2 doesn't go into 99, and neither does 7. This doesn't reduce. 14/99 is the fraction. Okay, next, 0.27. First, we want to start by looking at the multiples of 10 times x. And it looks like x and 100x will work for us here. So 100x is 27.27 repeating. And x is 0.27 repeating. Let's subtract these. We do get 99x's equals 27. We can divide by 99. This time we can reduce, dividing top and bottom by 9, and we get 3/11ths. Two more examples. These ones are intended to be a little bit more complicated. 0.48 with the 8 repeating. First, take a look at our options. We've got, it looks like 10x has 8 repeating and 100x. So those are the ones we're going to use. 100x is 48.8 repeating, and 10x is not 8. Let me fix that. 4.8 repeating. We go ahead and subtract. 100 minus 10 is 90. 48 minus 4 is 44. We can go ahead and just divide by 90. And 44/90ths does reduce, dividing top and bottom by 2 to 22/45. And I don't think that's going to reduce anymore. I'm going to check the answer on this one. 22/45 and 0.4888888. That's correct. Now let's try 0.726 with the 26 repeating. First, looking at our list, the first time you get the same decimal parts, the 26 repeating, is 10x and 1,000x. So we are going to use 10x and 1,000x. 1,000x is 726.26 repeating. 10x is 7.26 repeating. We go ahead and subtract those. This is 990x equals 719. 726 minus 7 will be 719. Divide both sides by 990. And 719 over 990 ends up not reducing, because 990 is just made up of 2 and 5 and 3 and 11. And none of those numbers actually go into 719. So it's not going to reduce. Now, in the assignment, on number 1, you're going to be changing these decimals into fractions. Please use the equation method. Number 2, you get to put the numbers in order. You're going to need to approximate them with a calculator so you can order them. 3 is solving for, find the area. You are going to have to use the Pythagorean theorem to solve for the height of that rhombus. Number 5, solve for g. 6 is a function dealing with the Pythagorean theorem. You just need to fill in the table. 7 has you give me a couple of examples of irrational functions. And 8 is a situation problem where you need to find the length of cable needed to replace the overhead line with one that goes under the street.